Okay, so I'm going to do this video real quick. We're going to try to keep it 5 minutes or under, which talks about the 3 modes of heat transfer. And we use 3 different demonstrations to show this today. The first one involved the radiometer, which you remember from Light Lab number 1 was that kind of light bulb looking thing that we shone a flashlight on and the panels began to move. The second one was a beaker with no water in it sitting on top of a hot plate. And the third one was the water in a beaker. Okay, and we use dye to show that as well. And what happened when we shine the light on the radiometer was that it would start to move the panels. But what I forced you or asked you to observe is not only what was happening, but also how was the heat from our source getting to the object. And so the heat source, in this case, in the radiometer, was a flashlight, and we wanted to observe how the heat was getting from the flashlight to the radiometer. And we said there that it was traveling through the air, that there was no touching. And we'll get back to that here in a little bit. And then the beaker with no water, we said that the molecules are moving from the hot plate to the beaker, and that has to do with direct touch. Okay, so the beaker is actually sitting on the hot plate. It's actually absorbing that heat, so it is coming through direct touch. And then the water in the beaker, what we saw was that we had movement when we put the dye in. We had a beaker, we had full of water, we put it above a Bunsen burner, and then we had a drop of dye that we put in. And what we saw was that the dye kind of sunk down along the sides, but then when it got to the middle, it started to go up towards the top, and then it made a circle. It kept going in this loop. It kept going in this loop, and the question I posed to everybody before they left was, what was causing that? And we'll get to that here in a second. Okay, and so what we see here is here's one of our modes of heat transfer, and this one is what we would call radiation. And radiation is the heat transfer that occurs without direct contact. So the example I have here, the alligators, would be obviously the heat is coming from the sun. The sun is not touching the alligators, but the sun is warming the alligators. So that would be radiation. Our second example, this one is one of direct touch. So this one is conduction. And conduction, just like the beaker on the hot plate, is involved when you're taking heat from one source, you're directly touching it to the other, and so it's transferring that heat that way. Just like the flame right here the heat from the flame is being transferred to this person's finger through conduction. The third form is a different one, and this is the same thing as demo number 3. The heat here is being transferred from the hair dryer to the woman's hair. And so it's not, in this case, it's not that heat is being transferred without touching, it's being transferred through a fluid. And when we say fluid, we mean that this could be a liquid or it could be a gas. Okay, so that's where we get the air, is that it could, this thing is not easy to write with. It could be a liquid like the water in our demo, or it could be a gas like the air here. Okay, so the heat here is being transferred by flowing air towards the hair. And this is what we would call convection. And convection is the big word that we are going to really worry about today. Okay, that's convection, or the transfer of heat through a fluid. And here, this one kind of shows all 3 of them. Radiation over here occurring, not direct touch, not transferred through a fluid, but it's just the heat is being transferred through no touch. Here, or convection, heat is being transferred. The heat from the bottom of the pot and pan is being transferred up and then it's coming back down. Conduction here, we have the direct touch, so the heat is being transferred from the pot handle to the hand. And these convection currents happen under the earth. So if we go back to convection, we're talking about fluids. Well, here's a perfect example, one in the real world. These convection currents occur underneath of the Earth's crust. And I have a little video here. It only lasts about a minute, and so we're going to go ahead and watch that real quick. That is, if I can get it to load here. Okay, I will play this real quick for you. At least I'm only going to show the first little bit of it.
It happens because hot rock rises, heated by the Earth's core. Near the surface, the rock spreads in two directions and goes sideways. It begins to lose heat. Eventually, the much cooler rock sinks back down. Through this spreading process, the Earth's crust is very slowly dragged apart. And it's this that ultimately causes the continents to move.
Okay, so Earth's crust being pulled apart, that's what we're seeing here. As we get into it, and we look a little bit more at this diagram, and like they were saying, we have the core down here, and the core is very hot. And so all that heat is concentrated kind of in here, and it's forcing the mantle or the rock, the molten rock, the magma, up towards the surface because it's getting warm. Just like in our demonstration, we could see the water was being forced up where the heat was, and as it was pushed out to the side, when it cooled off, it sunk back down. So as it sunk back down, it was forced back towards the middle, and then it would warm back up and go back up. But here's the interesting piece. So we have this crust, and as the mantle pulls to either side, as it begins to cool off, it's also going to pull on that crust. And this kind of works like a lava lamp, where we were talking about how it gets really warm at the bottom, gets really warm down here. Okay, if this was the lava, it gets really warm, shoots up, and then as it goes up, it cools off. But back to that crust, I'll skip ahead real quick. Back to that crust, with all of that crust being moved apart, with all of that crust being pulled apart, we have what we call continental drift. Okay, so to back up for a second and to kind of fill out these spaces that need filled out. Mantle, okay, this is just kind of a progression. We have at the very top, this is a cycle, and this is going to be kind of the cycle of the convection current. And so we have mantle rock cools, and when it cools, particles move slower, and when they move slower, particles occupy less space, and density increases. Mantle rock, after it cools and occupies less space, falls, and then the mantle rock, being closer to the core, is now heated, so density decreases, and the mantle rock particles move faster, occupy more space, the mantle rock rises, and it goes in this big cycle, just like we had said back on this page. So it gets heated, it becomes less dense, rises, cools, becomes more dense, falls, and it just goes in this big, and that is what we would call convection currents. Okay, and like I said, all of this leads to what we would call continental drift, and that is where we're going to pick up tomorrow with talking about Pangea, and you guys will get to see more of that tomorrow. Okay, so hopefully this helped. I will see you guys tomorrow.